All right, so welcome back to One Class. Again, my name is Joey. I'm going to be your math teacher for this session. Again, if you're tuning in for the first time, thank you so much for watching. Here at One Class, what we strive to do is that we are creating and curating these resources to solutions that are usually asked by frequently asked questions uh, through students like yourselves, you folks at home. So these topics, questions ranges from topics such as in secondary level chemistry and secondary level math as well. So our goal here at One Class is for me, is to verify these solutions so you get the best kind of resources moving forward to your classroom or in other future courses that you might have as well. A little bit about myself. Again, my name is Joey. I'm currently a secondary school educator residing in Toronto. And what I'm doing, my specialized subjects of interest are in chemistry and science as well as math. So, my responsibility is to kind of learn with you as well and teach you concepts through these questions that we have prepared for you. So, this next hour is going to be dedicated to about kind of pre-algebra, geometry, and also algebra 1 questions. And then the following hour at the noon mark, we're going to go into algebra and algebra 2 questions as well. So that's kind of my schedule for today. So without further ado, let's get started on these problems here. All right, so we have, this is a box, this is a question 1 here, and it says, oh, oops. So it says here a box. Pen's not working here. Just give me a second. Give me a second. So it says a box in a college bookstore contains books, and each book in the box is a history book, an English book, or a science book. If 1/3 of these books are history books and 1/6 of these are English books, what fraction of these books are science books? So let me see if my pen's working here again. It keeps zooming in for some reason. So sorry, just give me a second. Maybe I'll have to refresh the image here. There we go. Okay, so it says, so a bookstore contains books, and each book in the box is a history, English, or science book. So it says 1/3 of these are history books. Let me right here, 1/3. Question 1. So 1/3 of these guys are history books. History books. And then we have 1/6 of these are English books. English books. And then what fraction are science books, right? So there's three types of books here. So there's history, there's English, and there's science. And they're looking at what is the fraction books are of science books here. So what we have here is, what we're gonna do is we're gonna use something called the least common denominators. So if you look at the denominators here, I have 3 here and I have 6 here, right? So these two we have different denominators here. We want to convert them into the least common denominator. So in this case, 3 and 6, we have a least common denominator of 6, right? So in this case, I would change 1/3. I would change 1/3 into something under 6, right? And if I want to change that into this fraction here, I have to multiply the top and the bottom by 2. So this here is 1 by 2 times 2. 1 times here is 2 out of 6 here. So history books, 1/3 of them are history books. Also 2/6 of them are also history books as well. English is 1/6, right? And we have to figure out, okay, how many 6 are science books as well. So if you recall from how to learn about fractions, if I'm talking about fraction first, all my fractions have to add up to kind of like 1 here, right? Because I have you can think of it as, for example, you can think of it as I have 30 books in the bookstore, and I have to figure out, or in total, and I have to figure out how many of them are science books, right? So you can think of it as this, think of this question as this way as well. So you can say total books are 30. So you can say 1/3 of history books. So which is so history would be 1/3 of 30, which would be 10, and then 1/6 of 30, which is English, would be 5, right? So therefore, how many science books are left, right? Well, you can simply just do 10 plus 5 and subtract that from 30, right? So 30 minus 10 minus 5 would give me 15, right? So I have 15 science books left. But then the question's asking us, okay, what is it in a fraction, right? So which means I have 15 over 30 here, which would equal 15 over 30. If you reduce it, you can actually divide both terms here by 15, and you're going to get, you're going to divide both the numerator and the denominator by 15. You're going to get 1 over 2. And this here is your answer. Half of which is half of the library or half of the college bookstore contains science books here. If I were to use the first method that I kind of approached this question with, so I have 2, 6, 1, 6, and I'm looking for how many 6 are in science books. Well, 2 plus 1 is simply 2, 6 plus 3, 6 is simply 3, 6, and everything has to add up to 6 over 6, right? So therefore, if what number adds to 3, 6, obviously this would be 3 over 6 here, because 3 plus 3 equals 6, and 3, 6 here actually equals half. If you reduce this into its lowest common, if you reduce the 3, 6, and you divide the numerator and denominator by 3, you'd get 1/2 as well. So this here is the correct answer. Half of the books are indeed science books. Let's see here. We have 1/3 plus 1/6 equals 2/6 plus 1/6 equals 3/6 equals half of the total accounted for as history or English. To find the amount of science books, we need to just subtract half from the total amount. We don't have an actual total, but we have fractions of a total, and all the fractions of books should total 1. So this here is correct. So therefore, we subtract half from 1, which equals half here. So this solution here is correct. Good solution and answer. How you can approach this question is you can do it using fractions, or you can actually make up an arbitrary number. Right? You can say the total amount of books in the college bookstore are 30 or 100 or something like that. You get the same answer regardless because you're working in fractions, so it doesn't matter. In this case, we assume that there was 1 book in the bookstore, so therefore we had fractions of a single book. So either way, both solutions are correct. It all leads up to our answer, which is 1/2 here. So solution here is correct. All right, let's look at number 2. It says, what is the square root of 84? And again, I'm looking at this in simplified radical form here. There we go. So it says, what is the square root of 84? So in order for me to simplify this again, I can simply just divide this number by kind of its prime factorization, right? So what I can do is I can see which number divides into 84. So this would equal, if I have an even number which is 84, I would probably take out 2 first, right? So let me take out 2 first. So I have root 2 times, and then I would divide 84 by 84 divided by root 84 divided by root 82, which would equal root of 41 here. Or 42, sorry, 42. Again, I can do the exact same thing, and instead of working with 84, I will work with 42 now, right? So I have root 2 again here. I'm going to take it out another root 2 from 42, and then I'm going to divide 42 by 2, which will give me root of 21 here. And then finally, I can look at my my problem here. I could stop here and kind of simplify these root 2's, but I'm going to see how far this 21 breaks down here. So I have root 2 times root 2 times. If I take out, and I can't take out a 2 anymore because it's an odd number, but I can take out a 3, right? 3 goes into 21. So I would have root 3, and 21 divided by 3 here is root 7, right? So again, these two are prime numbers here. So again, all of these guys are now prime numbers, so I can simply simplify this here. Root 2 times root 2 is simply just 2 times root 3 times root 7. But however, I only want kind of one radical and one integer in my answer, so I have to convert this back into root 21. So this would be 2 root 21, or plus or minus root 21 here is the correct answer, because I'm multiplying 3 and 7 to get back whatever this one here, this guy here. So this here is our correct answer for the radical, for the kind of simplified radical form of root of 84. It's 2 root 21 here, or plus or minus 2 root 21, and this here they got a correct result. They just simply wrote the prime factorization out, and they just took root 2 times root 2, which gave us 2 here. So this here is correct here. Solution. So great. Solution and answer. Solution here is correct. Good. Let's look at number 3 here. It says this table represents a linear function. What is the slope of the function here? So let me just copy out this table here. X and Y, 1, 5, 2, 9, 3, 13, 4, and 17 here. So if you look how we calculate the slope of the function here, we can simply just take our first differences, right? So what does that mean by first? What do I mean by when I say first differences? Well, I'm basically going to look at 2 points of the graph. So look at these 2 points here, and I'm going to subtract the second term from the first term. So in this case, I know that my x's are increasing by 1, so I don't have to worry about my x's. These are my independent variables. So I'm not really concerned with these ones. As long as they're increasing linearly, it's fine. But what I have here, my y here, it says here, the table represents a linear function. So we already know it's linear, which is great. So how much is it increasing by? So 5 and 9. So I'm doing 9 minus 5 here is positive 4. 13 minus 9 is positive 4. And 17 minus 13 is positive 4, right? Therefore, my first differences here are positive 4, which means this proves that this is linear, but it also proves my slope. My slope here is 4. It's increasing by 4 every single time. If I were to graph this function, what I could do is I could take all these points and throw it onto a graph, right? So if I sketch out this graph for you here, I have 1, 2, 3, and 4. So I have 1, 5. So let me put 5 here. 1 and 5 would be this point. 9 would be here maybe. And then 13 would be here. And then 17 might be like here or something like that. If it extends all the way here, there, and we get something like this. So this here would be my graph here. And if you look at how do I calculate my slope using my graph, I can simply just say it's rise over run, right? Or I could simply just use the equation here, m equals y2 minus y1 or over x2 minus y1. So y2 minus y1 over x2 minus x1. This here, if I were to take out these 2 points, for example, so this is point 1 and point 2, I could simply just do y2 here is 9, y1 here is 5 over 2 minus 1. This is 4 over 1, which equals 4. So it doesn't matter which way you use it. You can solve it through the equation with the slope. You can solve it through first differences. Or what you can do is I can actually show you graphically what's happening, right? As you can see, I'm at 0 here. I'm moving up by or if I take these 2 points, let's just do these 2 points here. I'm moving up by 4 and up by 4 here, up by 4, and then right by 1, right? So rise over 1, run. The rise is 4, the run is 1, which equals 4 divided by 1, which equals 4, right? So either way, this graphically, solve it through graphically, solve it algebraically, or you can solve it for the first differences. It doesn't matter. This graph will give you a slope of 4 here. So so in this case they did they plot the points here, and they did the slope equation here, m equals y2 minus y1 over x2 minus x1. That's great. And they chose 2 points, and they calculated the slope, which equals 4. So great solution and analysis. So the solution here is correct as well. Now number 3, let's look at number 4. It says, how do you simplify square root of 52? So I'm simplifying the square root of 52. So, and again, just like question 2, how we're doing this is we're going to break this down into its prime factors, right? So again, 52 is an even number, so I'm going to choose to divide this number by 2 here first. So I have root 2, and then what's 52 divided by 2? It would be 26, right? And again, I have an even number again. I'm going to break this square root of 26 back into its prime factors again. And then I have root 2. So yeah, which means because it's an even number, I can take out root 2 again. So I'll take out root 2 again. And I'm left here with root 26 divided by 2 is 13 here. And I know 13 is a prime number, which means I can't break 13 into its other factors, which means I have to stop there. Which means root 2 times root 2, again, I just simply have 2 root 13. And plus or minus 2 root 13 here is my correct answer. And as you can see, this here is the correct answer as well. They did the exact same thing, and they broke it down to 2, 2, and 13, which is what I did here. And they simplified 2 root 2 times root 2 is simply just 2. So this here is a correct answer. Great answer, great solution and analysis here. So the solution is correct. And then we have a geometry question coming up. So this is number 5. Wow, we're actually speeding through this today, which is awesome. Maybe we'll pick more questions. I only picked 11 questions today. So hopefully, depending on time, I might have to re-pick some questions for you all. But we'll see how it goes today. So this is, what are coincident lines? So it's talking about this concept of coincident lines. So take a moment to think about this this answer here. What are coincident lines? Even though I guess the solution is kind of here, right? So you can kind of see what the solution here is as well. But think back to geometry when we talk about this concept of coincident lines here, and you can look at the solution if you're having trouble here. But how we define coincident lines is that they're basically the same line with the same slope. So they're basically the same line, or lines with same slope is probably a better way to say it. Lines with same slope. You can say and also kind of y-intercept as well. So basically they have the same slope, but they're basically you can basically lie them on top of each other and they would be the exact same line. So so let me draw something as well. So lines with the same slope, and when placed on top of each other, it becomes the same line. So let me just draw a set of coincident lines. So I have one line here and one line here as well. So I'm going to say these two are parallel lines. So they have the exact same slope, so same slopes. But what I can do is, if I were to place this on top of this line here, so I would get the exact same line. I would get a coincident line here as well. So in this case, this would be coincident lines here. So they're a special case of parallel lines. So lines with the same slope, and when placed on top, it becomes the same line here. So like they said before, it's just when two lines overlap or coincide with each other, they are coincident. That's good. So these two lines are coincident. They're parallel first, and then basically you place them on top of each other, and it is the exact same line. So basically, they also wrote analytically, which is fine. Basically, they're just saying they have the same slope, so same m value. But basically, what happens is that if they change the y-intercept, so in this case, if I change it from this point and this point here, I would get the exact same slope here, or exact same line. So this solution here, great solution and analysis. So again, coincident line is just a special case of parallel lines where if we do reflect them, or not reflect them, we do move them up or down or left or right, we get the exact same line here. As long as they have the same slope, then it is a coincident line. Special case, special subcategory of our parallel lines here. Okay, let's see. Solution to linear equation. So let's write this down. This is number 6. This is what is the solution to the linear equation 4b plus 6 equals 2 minus b plus 4. So 4b plus 6 equals 2 minus b plus 4. So to refer to this problem, what we're going to do is we're going to collect some like terms, right? So how we do this is we have to figure out which ones are like terms. So I have 4b and b here. These two are my like terms because they both have the variable b, and everything else is a number, right? So I can always simplify those ones first. So let me take care of the variables first. So I'm going to move minus b here to this left side here. Minus b becomes positive b, which means I have 5b here. So 4b plus b obviously equals 5b. And then I have plus 6 here. This is 2 plus 4, right? So I have 5b plus 6 and 2 plus 4. 5b plus 6 equals 2 plus 4 here is 6 as well. And then what we can do is we can move 6 to the other side, right? So 5b here, I can move 6 from positive 6 to negative 6, right? So 6, so I'm doing subtraction, I'm subtracting 6 from both sides here. 6 minus 6 here equals 0, so 0. And then if I divide both sides by 5 here, to get rid of the 5 in terms of with the b here, I'm going to get b here equals 0. 0 divided by 5 is 0, right? So in this case, my solution is kind of is satisfied if b here equals 0. And as you can see, we got the same answer as this student did as well. They also collected like terms, so they had 5b here equals 0. They divide both sides by 5, which is b equals 0. Therefore, b equals 0 is a solution to this linear equation. So the solution here is correct. Great solution and analysis. Okay. And then let's look at 70 here. Can the square root of 74 be simplified? So square root of 34. Again, we have these same problems. We have an even number. What we can do is we can take out another even number, right? We're always taking out 2 here. So we take out 2 here. We get root 2 times 34 divided by 2 gives us root 17 here. And 17 here is our prime number. So in this case, we can't simplify this anymore. So therefore, like the most simplified form, if you think about it in terms of radicals, is actually here. Root 34 here. So when we say can the square root of 34 be simplified, technically no, because root 34 we leave it as root 34 because we can't break it down into more radicals here. But what I think what the student did was they actually calculated what the exact value of square root of 34 is. Again, what we could do is we could always use a calculator and solve for this here. So root 34 would equal about 5.83, and that's what they're doing here. So they're using the concept of long division to figure out what the square root of 34 is. So let me just go over the solution with you as well. So they're basically just using the same thing as long division. And sometimes we have to if they're asking us what the approximate value of square root of 34, if the question was asking, what is the approximate value of square root of 34, we would definitely use this method here. But it was asking us, can the square root of 34 be simplified? In this case, I would answer no, because it can't be. We're not simplifying this radical and breaking it down to an integer and a radical. But what we're doing is we're actually approximating what this square root is here. So let me just walk through the solution as well. Basically, they're just using the concept of long division, right? So they have 5 and 34 here. And what they're doing is 5 squared is 25, and that's the closest to 34, right? So 5 squared is 25 here. So I would get 34 minus 25, which would equal 9. And what I could do is I can bring down another 0 here. Basically, I'm adding 0, 0. Bring down a 0 here. And then what I can do here is I can bring down zeros, and then what it's telling us to do is I have here, I'm taking the value of 8. So it says here, step 2 says, now take the next term as 0 and use decimal in the quotient to solve it further by taking value of 8, since 108 times 8 equals 864 here, which is less than 100. Let's see. So I'm just figuring out where they're getting 108 here. So okay. Oh, I have 10 here first. Sorry. Because again, I have 5 plus 5 times 2 here is 10. That's good. And then I'm taking the value of 8 here. So I have 10 here, and what it's doing is that here I have a 10 here first, and then I'm taking the next term, which is 0, and we use decimal in the quotient to solve it further by taking the value of 8. So this guy becomes 108 here. This is 900 here, and then 5 times 8 here would be 864, which is less than 900. Subtract that, you get 36. And then finally, what you could do is that you could take another, you can add 2 zeros again, and then we would have something like this. So if you add 2 zeros, we bring down more zeros here. We get a new value here. This is 1163, and we get that from basically 116 here, right? Because what we're doing is we have 116, and then we're taking out the 3 from the first decimal place here. Well, not the first decimal, but the first kind of placeholder value here, and then we would realize that 163 times 3 is closest to 3600. So therefore, this is our answer here. So square root of 34 is approximately 5.83. So this here, if you were to approximate square roots, I would get something like this. However, the question was asking us, can the square root of 34 be simplified? So in this case, I would write just simply no here. So this, so they gave us some solution in terms of what this is in decimals, but so technically it's still the correct answer. So correct solution, but I think the student was asking about a simplified radical form rather than a approximation of the square root. If so, the square root of 34 cannot be simplified. So that's okay. Let's work on number 8 here. So number 8 says that how many 8-ounce glasses are in a gallon? So 8-ounce glasses in a gallon. So again, what we're figuring out is that we need our empirical system. We need our table here, right? So let me write this down first. So I have 8-ounce glasses in a gallon. And then we are figuring out how many 8-ounce glasses are in a gallon. So, and we have to kind of write down our table for empirical systems, right? So we have 1 gallon here equals 4 quarts. 1 quart equals 2 pints. 1 pint here equals 2 cups. And then 1 cup equals 8 fluid ounces, right? Fluid ounces. So we're talking about how many fluid ounces in 1 gallon, right? So what we're gonna have to use this concept of dimensional analysis in order to figure this question out. So I'm gonna actually leave you for a sec. You can take a minute to do this question. I just have to run and do an errand real quick. I'm so sorry for leaving you guys. I'll give you guys 1 minute to figure out this question here, and I'll be back in a sec. Just give me a second here. Sorry, guys. All right, sorry folks. All right, I'm back. Sorry, Amazon package came. Okay, so let's solve this problem here. I left you a problem saying that how many 8-ounce glasses are in a gallon. So we have to use again this concept of dimensional analysis for us to solve this problem. So how do we do that? Well, we have a gallon here first. So let me just do some blue here. So we have a gallon here, and what we want to do is we want to convert all the way down to fluid ounces here, because we're talking about how many glasses, right? So in order for us to do that, we are going to calculate here how many ounces are in a gallon first. So let me just do this problem quickly. And how we do that is we're taking 1 gallon. So we have what we're starting off is we have 1 gallon here. So 1 gallon. We want to change this first from gallons to quarts, and from quarts to pints, and from pints to cups, and then finally from cups to fluid ounces, right? So let's say 1 gallon here, I know it equals 4 quarts, right? There's 4 quarts here divided by 1 gallon. I know there's 4 quarts in a gallon. There are 2 pints in 1 quart. There are also 2 cups in a pint. And finally, from 2 cups in a pint, we have 8 fluid ounces in 1 cup, right? So this here is our kind of our analysis here for to solve for how many fluid ounces there are in a gallon. So in order for us to do that, we basically have to multiply all the way through, right? So we have 1 gallon. So my gallons are going to cancel out here. My quarts are going to cancel out. Pints are going to cancel out. And my cups are going to cancel out here, which will leave me with fluid ounces here. And that's kind of my unit of interest here. So I have 1 times 4, which is 4, times 2 is 8, times 2 is 16, and then 16 times 8 here is going to be basically how many fluid ounces I have. Let me do that quickly. 16 times 8 would equal 128 ounces. 128 fluid ounces in 1 gallon, right? So I have 128 fluid ounces here. So let me rewrite this here. I'll write in blue, sure. So it says 1 gallon equals 128 fluid ounces. And it's now asking us how many 8-ounce glasses are in a gallon, right? So if I know that 1 gallon equals 128 fluid ounces, I can now finally relate this. I have this relation here, which is 128 ounces. And what I'm going to do is I'm going to multiply that by, I have in 1 ounce glass, in 1 glass here, there are 8 ounces, right? There are 8 fluid ounces here. So it's asking us how many of these glasses here are in a gallon. And I have, again, one glass has 8 fluid ounces here, right? So I have 128 times 1 over 8, or I can say 128 divided by 8 here. And let me just correct my units here. This is 128 fluid ounces. I don't know why there we go, 128 fluid ounces. So these fluid ounces cancel out. I have 128 times 1 over 8, or 128 divided by 8, and this would give me 16, and then I'm left with just glasses here, right? That's going to be my unit of choice here. 16 glasses will be the correct answer for this solution here. So it says here, a gallon is a unit of volume. That's good. Ounces is a unit of weight. So in order for us to convert gallons into ounces, where 1 gallon is showing 128 ounces. So they simply just stated this. I don't know if that's kind of common knowledge, where 1 gallon is 128 ounces. I solved for that initially through this this dimensional analysis here. But again, if that's common knowledge, then you can definitely just use 128. That's totally fine. And if we need 8-ounce kind of glasses in a gallon, then we're simply just dividing. And that's what we're doing here. We're dividing. We're multiplying by 1 over 8, which is the same thing as dividing by 8 here. And we can calculate how many glasses here, glasses of 8 ounces, 8 fluid ounces there are in a gallon here. So this solution here is correct. Great solution and analysis. Not sure if 1 gallon equals 128 ounces is common knowledge, but correct nonetheless. Solution here is correct. That's awesome. So that was number 8. Let's look at number 9. It says, how do you write 1/6 in percent? So how do you write 1/6 in percentage or percents? How we have to do this is we have to basically convert this into a decimal first. So we have 1/6 here. In order for us to convert into decimals, what we're going to do is we're going to do 6 divided by 1 here. So you have 6 here, or 1 divided by 6, you can say. Sorry, yeah, 1 divided by 6 is probably, yeah, it's the correct way of saying it. Sorry, it's 1 divided by 6 here. So we have 1 divided by 6, and we're going to add these placeholder zeros here. And then we're going to do this through long division. So my decimal place is still here. I'm going to have 0 in this first slot here. 6 times what number would give me closest to 10? It would be 6 here. 6 times, or sorry, it's 1 here, sorry. 6 times 1 here would equal 6. 10 minus 6 here is 4. Bring down the 0. 6 times what number would equal 40 or closest to 40? It would be 6. 6 times 6 here is 36. 40 minus 36 here is 4. And then, as you can see, this kind of process repeats, right? It repeats for every time we do add a decimal place here. So again, it's 0.16 again here. And this would be 36. 40 minus 36 is 4. You bring down the 0, and then you can repeat this as well. So this 6 here is repeating. So therefore, 1/6 here in decimals first. So this is simply in decimals. Would be 0.16, and then the repeating sign here, right? So basically what I have here is I can say it's 0.1666, right? In order for us to convert simply this to percentage, what we're going to have to do is we're going to multiply the decimal by 100%, right? So this here would equal, I can move the decimal place 1 and then 2, so my new number here is 16.66%, and this here will be my correct answer for this solution here. 16.66% is 1/6 in percentage. So this here is this solution is correct as well. In the given case, you have to convert 1/6 to percentage form. So multiply 1/6 by 100, you would get 16.67%. I did it first in decimals. In percentage, it doesn't really matter. You can actually go directly from fractions to decimals by simply just taking 1/6 times 100% here, and you would get exactly the same thing. 16.66% here. So it doesn't matter which way you do it. Both solutions here are correct. So I'm going to write here, great solution. And analysis here. So solution here is correct. That's good. That's number 9. We have 2 more questions for today. Probably going to end early, but it's totally fine. We did a lot of math today. So it says, what value of x will make the triangle similar by the SSS similarity theorem? So let's do, this here is 10. So we have 2 triangles here. One triangle is 22, 22, and x. And I have another triangle here. The size, it's not to scale, obviously. 15, 10, and 10 here. It's asking us what value of x will make this triangle similar by SSS similarity theorem. So when we talk about SSS similarity theorem, we're talking it's side, 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 right? So SSS is side, side, side. Where did my pen go here? There we go. SSS similarity theorem states that sides, basically all sides, have to be are proportional in order for us to assume that the triangle is similar. All sides are proportional for triangle to be similar. So what we can do with with this one here is that we have we have 22 and 22 and 10 and 10 here. So we can assume that that is going to be my ratio here, right? I have 22 and 22, and then I have 10 and 10. So these two sides are good already. So these two sides are good. So the bottom of the base of the triangle is good. The one of the sides is good here. So I can say this ratio is correct. It's 10 to 22 here will be the ratio, right? So I'm going to set up a ratio and say the proportion is from basically from triangle 1 to triangle 2. So this is 10 over 22, which is kind of our ratio here. 10 one side here over 22 equals, it would be equal, again, this side over this side, right? So 15 over x here. 15 over x, because that's what we're solving for, right? So again, these top two terms are from triangle EFG. EFG over, this is from IHJ here. Triangle IHJ. So these two, again, I'm just creating simply a proportion in order for us to solve for this x value here. So let's solve this. We would cross multiply to solve for this here. So I have 10 times x, which is simply just 10x. And then 15 times 22 would give me 330. Again, in order for us to cross multiply, it's 10 times x here and 22 times 15 here. To get us this algebraic equation here, I can divide both sides by 10 here. Okay, x equals 330 divided by 10 would give me 33. So x would equal 33 for this side to make the triangles similar by side similarity theorem here. So as you can see, they also made a I believe they made, yes, they also made a proportion here. 22 over 10 equals x over 15. That's the exact same thing as mine, except they used the reciprocal, so they flipped it. So they wrote, instead of 10 over 22, they wrote 22 over 10 equals x over 15. Doesn't matter. It'll still give us this kind of algebraic equation here, which is 10x equals 330 divided by 10 here, and therefore x equals 33. So this solution here is correct. Solution is correct. Great analysis. Solution is correct for equals 33. That's good. That was number 10. And finally, our last question of the day. This will be our 11th question. So 11th says that how many ounces are in 500 milliliters? So is my pen working? No. Oh, there we go. 11 says how many ounces are in 500 milliliters? So for us to solve for this one, what we're doing is we're converting from the empirical into the metric system. So this is from the empirical to metric system. So in order for us to do that, we basically get a weird conversion, because when we're talking about the metric system, it's by tens, right? We have millimeters or milliliters, liters, and then we have centiliters, decaliters, and so forth. The metric system is by 10, whereas the empirical system is not. The empirical system was formed on a different basis here. So in order for us to do that, we basically have to basically look up a conversion for empirical to metric formulas here. So it says ounces. So from ounces to milliliters. So it says here 1 fluid ounce would equal 29.5735 liters here, right? So in order for us to do that, that's from ounces to milliliters. But what if I want to go from milliliters to ounces? Go backwards, I would have to do 1 divided by 29.6 here. So I'm going to write here, it says 1 milliliter, 1 milliliter equals 0.0333814, would be my my ounces here, my fluid ounces here. So if I were to say if 1 milliliter, if I can use this conversion, what I can do is, again, I could use this concept of unit analysis to solve for my ounces here. So if I have 500 milliliters to begin with, I'm going to have to multiply it by how many ounces are in a milliliter. I have 0.033814, right? So in order for us to do this, I have 0.033814 fluid ounces per 1 milliliter here. So I'm simply just, my milliliters cancel out, so therefore I'm just simply doing 500 times 0.033814, which will give us 500. I'm going to use my calculator here, 0.033814, which will give us a value of 16.907 here. And this is our correct solution, 16.907 fluid ounces. And this here is our correct answer for how many ounces are in 500 milliliters. 16.907 is my ounces per 500 milliliter. And again, they have the exact same answer here. So this solution here is correct. So again, we're going to end slightly early today, but that's totally fine. Again, we finished 11 problems today, and that's all the problems I have for these concepts were probably pre-algebra, geometry, and algebra 1 questions for today, for this hour especially. So again, thank you so much for watching our stream here today. Again, you can tune in at 12. I'm going to be doing questions from basically Algebra 1 and from Algebra 2 here. So we're probably looking at quadratic equations specifically, and I'm going to do an hour of kind of answering your problems about those questions as well. So if you want to stay and tune in for that, that's awesome. Again, my name is Joey. I basically stream from Monday, Wednesday, and Friday to solve for math questions, and then chemistry questions would be Tuesdays and Thursdays. So as always, again, thank you so much for watching. Stay safe, stay healthy, and I'll see you in the next stream. So take care.